Now comes the hard part, making the left-hand side crankcase. This would require me to laminate two pieces of polystyrene together to get the required thickness to machine out the pattern. And for those of you wondering, hot glue is 100% not the ticket for laminating sheets of extruded polystyrene. My first attempt at machining the foam ended in disaster. Well, maybe that's a bit dramatic, but at the halfway point the cutter became gummed up with hot glue as the glue reactivated and bonded itself to the cutter. This both ruined the pattern and wasted a good couple of hours. So the logical thing to do was visit the local hardware store and buy some PVA glue. I cut new pieces of foam and clamped them together overnight with a thin smear of glue painted between them. This worked, but next time I will try using shellac to bond the pieces of foam as the PVA struggles to dry in the middle. So this was the same cutter and setup as the right hand side case I cast first, done in 4 operations totaling about 2 hours give or take. I'd have to say it is probably the most mind-numbing part of the entire process, standing around holding a vacuum cleaner. I found the PVA glue better, but to a small degree it would still gum up the cutter between operations. You can see here I have about 70mm of stick out with the 8mm 3-flute end mill. This has zero deflection when cutting foam. I can only imagine machining this from billet, as that would be a completely different story, requiring far less stick out, and there would be a lot more tool deflection. I also wouldn't be doing no 20mm deep cuts with 5mm stepovers on each pass. Programming these toolpaths doesn't take as long as you'd think. Thanks to Fusion's 3D adaptive toolpath, all I do is tell it what the tool is, my desired cutting parameters, and where I don't want it to cut, as by default it will attempt to machine everything. This function saves you clicking on all of the individual features on the model. From there I can simulate everything in Fusion before cutting any material. Although useful, the simulation doesn't take types of glue into account or any trouble you may encounter. With this pattern, I was really worried about the aluminium freezing before getting into all of the narrow passages, so I decided to add a gate to the sprue. I ran the calcs with the guesstimator and Mark 1 eyeball and everything seemed legit. This then presented me with more worries. What if I overgate it and I can't keep up with the pour and the mould collapses? I trusted the calcs and just decided to run with it. I'd cross that bridge when I get there. So everything from here is the same as last time. I used my Budjo hot glue gun and sticks, and a watery mix of Jib 4+ and a paintbrush to put the 2 coats on the pattern. In my opinion, I would have to say, for my best guesswork, it looks pretty professional. Now all that's left to do is fill the crucible with all of the ingots I prepared earlier. I worked out the required weight by using the properties of the solid model in Fusion 360. So I would have the exact right amount of aluminium. And we're jumping straight into the pour. 4 kilos of aluminium at 880 degrees. Here's the barbecue tongs earning their keep as they remove all the slag from the top of the molten aluminium. I would have preferred a ladle, but these are just what we had lying around. You might also notice that the face shield has been activated for this pour, actually providing some protection, unlike last time. I had no idea if I had enough aluminium or not, as I couldn't see 7/10 of fuck all because of the big flames and all of the black smoke coming out of the mould. That's why I overfilled it and some spilt out. When the smoke cleared, I was relieved to see aluminium in the pouring basin. This meant the mould was full, which was a relief as I had absolutely no aluminium to spare. And the moment of truth. Waiting about 20 minutes and kicking over the bucket, I was relieved that the pattern was fully formed, although there were a couple of minor defects. There were a couple of small leakers where aluminium had breached the mould. This happened because I was too lazy to buy a sieve to run the sand through and applied the she'll be right mentality, and my turbine vibrator for compacting the sand wasn't strong enough, so maybe next time I'll need to add another 2. Most of the leakers came off with a chisel and a die grinder. There was a rather large one that required a fair bit of grinding and a couple of flakes on the lower cylinder face. I'm not 100% sure what caused these. With a bit of elbow grease, I will be able to use this casting, and it is not a failure, although I have some new insight to apply to the next pour, whatever that is. The next step is to machine this crankcase half and mate it to the other half.